I would like to recommend the F453 Revision Guide by Jake Wright, a computer science student who has recently graduated from Cambridge. It is a short book written specifically for the OCR GCE Computing F453 course and provides notes on all topics in the subject, making it extremely useful for revision. Welcome to F453 by Jam. Today we are covering Chapter 1, the functions of operating systems. We will be going over Introduction to Operating Systems, Interrupts, Scheduling, Memory Management, and an overview of modern operating systems. The tasks of operating systems. An operating system is low-level software used to perform daily tasks. Windows, Mac, and Linux are all examples of operating systems. An operating system has a number of jobs to do. It must provide and manage hardware resources such as memory management and jobs passing through memory. Provide an interface between user and machine, commonly known as the human-computer interface, covered in F451. Provide an interface between hardware and software so that they can communicate with each other. This would include the memory location of the keyboard, for example. Provide security for the data on the system, for example encrypting files. Provide utility software to maintain the system. Here is a diagram showing interactions between the different levels. Don't forget about security or utility. Interrupts. Suppose you are in your house, performing daily tasks. Then your house catches on fire. Ah! You must switch to a new task, getting out as soon as possible. You have interrupted what you are currently doing to perform a task with higher priority. Let's see how operating systems can make use of interrupts. Interrupts are signals sent to the processor to obtain processing time. Each interrupt has a priority, and some interrupts have higher priority than others. An example of a high priority interrupt is a power supply unit failure. Interrupts are held in a queue. After every CPU cycle, the queue is checked for an interrupt with a higher priority than the current job. If one is found, then the interrupt is executed. Executing an interrupt will interrupt the regular cycle. The data from the registers are copied to a stack in primary memory, and the interrupt service routine, ISR, is executed. The registers are then reloaded with the original instructions, and the original job is resumed. There are 4 types of interrupt: input-output, such as a keyboard press; timer interrupt, where the processor must attend to time-specific activities; hardware error, such as a PSU failure; and a program interrupt, generated due to an error in a program. Scheduling. Have you created a revision timetable? Organizing the tasks that need to be done is crucial to success. If you can stick to an effective schedule, then you have maximized your efficiency. Let's see how operating systems make use of scheduling. To make an effective schedule, we first lay out the goals of our scheduler. A scheduler should maximize the performance of the CPU system. It should be fair to all users. It should provide reasonable response times so that delays are not noticed by the user. Overloading should be prevented at all costs, as this could lead to a system failure. It should ensure consistency by handling similar situations in the same way. A job has 3 states: ready, running, or not ready. The job may not be ready because it is waiting for a peripheral, for example. The scheduler a program used by the OS to control jobs, has three main parts. The high-level scheduler places jobs into the ready queue. It is also responsible for making sure the system isn't overloaded. The medium-level scheduler swaps between main memory and the backing store. The low-level scheduler moves jobs in and out of the ready state. It decides the order in which jobs are placed in the running state, using scheduling algorithms. There are two types of scheduler. Preemptive, meaning jobs can be interrupted while in the running state, and non-preemptive, where they can't be interrupted. A scheduling algorithm is a small program used by the low-level scheduler. There is first come, first served, where jobs are completed in their entirety before moving on to the next one. For this reason, it favors long jobs. Round robin, where each job is given the time to complete before being sent to the back of the queue. Shortest job first, where the shortest job is moved to the front of the queue. Shortest remaining time is very similar to shortest job first, but a newer, shorter job will out-prioritize the current job. Multi-level feedback queues use several queues where jobs move downwards as they use more processing time. Round robin is used at the lowest queue. You may be asked to list the advantages and disadvantages of the different algorithms. Long jobs on the shortest remaining time algorithm may take a very long time to be addressed, because all it takes is for a new, shorter job to come in. First come, first serve is the most simple algorithm, but longer jobs may waste processing time by making shorter jobs wait. Multi-level feedback queues are efficient, but are the hardest to understand, which is why I have constructed an animation to demonstrate how it works. A new job will start at the highest priority. When it gets to the front of the queue, it will be processed. At a given queue level, a job is given a certain time to complete. If it does not finish in this time, it will be moved down to the next queue, the priority 2 queue. It will be processed again when it gets to the front of this queue, but given a shorter time this time. The processing time is what makes the levels of priority effective. If the job fails to complete, it will move down to the next queue. We are now down at the lowest priority queue. When it gets to the front of the queue, it is processed again for a very short time. The job is then moved to the back of the queue. Round robin is used at the lowest level, so it will cycle through this queue until it completes. Jobs have two types. Input-output bound jobs, such as a key press, require fewer calculations and therefore take up a small amount of processor time. They are handled before processor-bound jobs, because they take up more processor time. Memory management. Memory management is essential. It is sometimes useful to contextualize something you are trying to remember. This is because sometimes being able to make a link or pattern to the information can be more effective than trying to revise the information itself. We allocate memory to allow separate processes to run simultaneously. We reallocate memory when necessary, otherwise a job that is finished would still take up the memory space. Processes must be protected from each other, so that one job cannot intrude another. Memory management is used to deal with virtual memory, paging, and segmentation, which are solutions to a memory management problem we'll be learning about shortly. A job must be stored in the computer's memory in order to be processed. Primary memory can be imagined as a stack, which is a last-in, first-out data structure. Here is an example of primary memory. The OS has its own reserved memory, called wired memory. Suppose that job C terminates and job E in the ready queue requires 30 kilobytes of memory. We have a problem. There is definitely 30 kilobytes of memory free, but job E cannot fit in either of the three spaces. You could wait for a larger gap, but this would be a bad use of resources and take a long time. Job D could be moved down, but this would make heavy use of the processor. 20 kilobytes is a lot to reallocate, and processor time is better spent on other issues. Job E could be split into two parts, but this could cause fragmentation errors. Virtual memory, paging, and segmentation were implemented to solve this problem. Virtual memory is a part of the backing store. When you minimize a video, it is still running in the background, but we don't need to display it. The video instructions may have been passed to virtual memory, an alternate set of memory addresses located on the hard disk. It has the same format as RAM. It gives the illusion that there is more physical memory than there actually is, as we can store jobs that are larger than the primary memory. When we maximize the video we are watching, the video instructions must be passed back to primary memory so they can be processed. The process of translating a virtual address to a physical one is called virtual address translation. Virtual memory could be the solution to our problem earlier by moving a lounging job into virtual memory. Disk thrashing or threshing is a side effect of virtual memory. It occurs when more time is spent translating memory than processing. It is often caused by insufficient memory. The computer may hang, meaning it stops responding to inputs. There are two methods of partitioning memory, paging and segmentation. Paging uses fixed size memory allocations, and larger jobs can take up multiple pages, but no two jobs share a page. There are index references to each job. Paging could be the solution to our previous problem. There would have been enough space left over. On the other hand, segmentation uses variable size memory allocations. It relies on logical breaks in the code to separate its sections. Space is not wasted, unlike paging, and it also has index references to both jobs. Spooling is another memory management technique. Job references are stored in a spool queue while waiting for other processes to complete. A common example you should remember is print spooling. The processor can do other tasks while the slow process of printing finishes. When the printer is ready for the next document, the printer will send an interrupt, and the processor will assign the correct job to the printer using the spool queue. This is what a hard disk looks like. There are some terms you need to know. A track is a ring around the disk. The sector makes up a sector of the disk. A block or cluster is the smallest memory space you can allocate to a file, typically 2 or 4 kilobytes. Multiple clusters are what makes up a file, and this is also called a chain. The file allocation table stores records about the hard disk. The FAT file will store information about each cluster in a file. It knows where the next cluster in a file is, and has flags indicating if it is the last cluster, a bad unusable cluster, a reserved cluster, or a free cluster. Note that the FAT file does not store the first position of a cluster in a file. That is done by the directory table. This stores information that you're probably familiar with, such as file name, extension, file size, etc. Modern operating systems. You are probably viewing this video on a modern operating system. Modern operating systems have many similarities. Let's explore them. Command line interface and graphical user interface are the main two types of operating system. They are covered in F451. MS-DOS is a command line interface. Windows has a GUI. Modern operating systems are multitasking. You can easily switch between different applications at any time. Modern operating systems undergo the boot process, a process used to initialize the computer, which we'll cover in more detail now. Firstly, the computer must be switched on. This is generally done by pressing a button. The first thing the CPU will do is look for the BIOS. The BIOS is stored in ROM, but user configurable parts are stored in CMOS RAM. The BIOS then runs its power-on self-test, diagnosing itself for problems. If something is not working properly, the BIOS issues an error message in the form of a text or series of coded beeps, providing information of the nature of the problem. During this stage, CPU registers are also cleared. If everything is A-OK, the boot program is loaded, and the address of the first instruction is placed in the program counter. The boot program looks for an operating system to load. When one is found, the operating system will take control of the rest of the boot process. The boot process is a complicated one. Try to memorize the basic steps first, as they are what are usually asked for in the exam. That's all my slides. Thank you for watching. Strike that like button and subscribe for more F453 related content.